Yeah. Good afternoon, my dear students. We're going to start the class now. Just mute everybody. It is a lot of disturbances I'm getting. Yeah. See, in the morning session, I was just discussing regarding the processing of polymers, the last class on processing of polymers. And we have discussed quite a number of processing techniques. Okay. So I think you can look at the PowerPoint presentation or the notes what I already been shared in the Google Classroom. Okay, so you can prepare for the processing of polymers with the different techniques and everything. Okay, so that is the completion of the concepts of polymers. In today's session, we're going to start with the second part of the module 3, which is powder metallurgy. This, I don't know whether you have studied this concept of powder metallurgy in your material science or your manufacturing processes. But this process is quite a fast-coming process, and I have quite a number of applications also. So when you look at many of the automobile parts or industrial application parts or medical parts, they have been manufactured by powder metallurgy technique. So this concept, how the products can be manufactured by the powder metallurgy concepts. Okay, so in this entire concept of powder metallurgy, so we will be discussing the general concepts, the powder production techniques, characterization techniques, the microstructure control in powder, and powder shaping and sintering, and finally we will have applications of powder metallurgy. So you will have one full question from powder metallurgy concept. So you will have interval charts with respect to the powder metallurgy and the polymers. Okay. So let us today we will going to start with the general concepts of powder metallurgy. So in this we will going to understand what is powder metallurgy and what is the history of powder metallurgy and what is the renaissance, what revolutions has been taken place in the field of powder metallurgy process. And later part we'll be discussing what are the, what we call it as the scopes of powder metallurgy. Okay. First, we're going to start with the general concepts. Yeah. See, when you look at the general concepts here, the powder metallurgy is a metal processing technology in which the parts are produced from metallic powders. See what the processing techniques or processing production techniques or production methods what you have discussed. So either whether the product or the raw material which will be in the form of a solid or it might be in the form of a liquid in the case of the polymers. But this technology is a totally, it is a new technology. New technology in the sense it is a different technology. It is a very old technology, not a new technology. But it has been evolved over a period of time, and it has been used to its maximum extent nowadays. So because of its quite a number of advantages and application oriented. So this metallurgy or powder metallurgy concept has been used. What actually you mean by powder metallurgy? A metal processing technology in which the parts are produced from the metallic powders. So here the raw materials will be in the form of powders, and powders are being processed and it will be given a required shape and required size. So this is the concept what we are discussing. It is totally, it is a very different technology what we are having. Okay, so these powder metallurgy parts can be mass produced to a net shape or near net shape, eliminating or reducing the need for subsequent machining. In the sense, in this powder metallurgy process, you can obtain the parts which are near to the net shape. Net shape in the sense you can obtain up to the closer dimensional tolerances, okay, and closer surface tolerances, everything you can obtain. And once you reach or once you obtain the net shape, near net shape or the net shape, definitely you can eliminate the machining. So machining is basically it is a secondary process. After this, once it is just especially in the case of a castings. Okay, so once you cannot achieve close dimensional accuracies in the case of a casting on surface roughness, surface finishes also. In such cases, casting needs to be undergoing a machining. But in the case of a powder metallurgy, you can produce the parts directly to the net shape or near to the net shape. And once you get the net shape or required near to the net shape, definitely you can eliminate the machining processes, the secondary processes. That is one of the major important advantage of this powder metallurgy. And also, certain metals that are difficult to fabricate by other methods can be shaped by powder metallurgy. Just like a tungsten. Tungsten, basically, you cannot fabricate by any other manufacturing methods. So tungsten basically it is used in used as a filament in the lamp. Okay, bulbs, actually bulbs, and these tungsten cannot be processed by any other methods. But you can use this tungsten for making the filaments using the powder metallurgy technique. This is another one important point that needs to be observed in the case of a powder metallurgy. And the PM process based on very little material. 97% of starting powders are converted to the product. So in a sense, the wastage of material is very less. So when you do casting or when you do machining, metal removal process, so definitely you will find a lot of material is wasted. Okay, of course, sometimes we need to obtain required dimensions or required surface finish. Definitely, it needs to undergo. We need to remove the material from the final products. So in such cases, there will be a wastage of materials and loss of materials also. So therefore, in this case of powder metallurgy, there will be no wastage. Almost 97% of the starting powders are converted to the product. The powder metallurgy parts can be made with a specific level of porosity to produce porous metal parts. So another one important. So porosity is a very important property. So certain materials may need a porous materials. So when you want to process the porous materials, or if you want to import a certain specific level of porosity to the product, so we can make use of this powder metallurgy technique. Okay, that is another one important point from the manufacturing, from the powder metallurgy point. The examples: filters. Filter is a porous metal, porous part, oil impregnated bearings, and gears. So these are all what we call it as the porous materials, which you can directly obtain from powder metallurgy technique. Now coming to the introduction part. Earliest use of iron powders dates back to 3000 BC. Egyptians used it for making iron powders. So the history of the powder metallurgy starts from 3000 BC from Egypt, where the iron powders were used for making the tools. Modern era of powder metallurgy begins when tungsten lamp filaments were developed by Edison. So it was started in 3000 BC, but modern era, which was started with an Edison, where he is want to manufacture and was to develop tungsten filament, lamp filaments. Components can be made from pure metals, alloys, or mixture of metallic and non-metallic powders. So you can use either a pure metal powders or alloys or mixture of metallic and non-metallic. So anything, any flexibility we are having in case of manufacturing or using this kind of technique. Okay. Commonly used materials are iron, copper, aluminum, nickel, titanium, brass, bronze, steels, and refractory metals. In the sense, in this case, so the different materials, what we can use: iron, copper, aluminum, nickel, and widely used for manufacturing gears, cams, bushings, cutting tools, piston rings, connecting rods, and so here they have given a few very important examples are quite commonly used manufacturing technique, the powder metallurgy technique for manufacturing certain parts, such as gears, cams, bushings, and cutting tools, piston rings, connecting rods, and impellers. Apart from that, there are plenty of applications for that. As we go ahead, we will go to discuss each one by one. Okay. Powder metallurgy is a forming technique. It is an art and science of producing metal and metallic powders and using them to make a finished or semi-finished product. Particulate technology is probably the oldest forming technique known to man. They say this is the oldest technology. It is a forming technique where you can form the components. And basically, it is an art and science of producing the metal powders. See here, the two important things here is you have to produce the powders and then you have to process the powders to obtain or to get the finished and semi-finished product. So the two different levels of manufacturing. One is producing the metallic powders and using this metallic powders for obtaining the finished or semi-finished product. And this is the oldest forming technique which is known. There are archaeological evidences to prove that the ancient man knew something about it. And of course, they say the ancient man, he also been used this kind of technique. And of course, for that we have archaeological evidences also. Okay. Just coming to the history, it is iron metallurgy. That's what I was talking about in 3000 BC by Egyptian. They used to use iron powders to making tools. And how did man make iron in 3000 BC? He have furnaces to melt iron, air blast, and the reduced material which would then be spongy. Used to be hammered to a solid or to a near solid mass. Example, iron pillar at Delhi. Quite unlikely, then how? So what is here is, if iron, it has been iron pillar at Delhi. It is the very oldest thing you can see. If it is happening in very long back, how people they used to manufacture or they used to get iron. That's what iron metallurgy. How did the man make iron in 3000 BC? Want to make a tools. How he used to do? Whether he had furnaces to melt iron air blast? No, at that time it was not there. So then he was hammered to a solid or to a near solid mass. How he has got this? So this is what the history of powder metallurgy will come into the picture. As we go back, as we look at the back, so you can see the powder metallurgy is one of the oldest forming techniques what they have been, and of course it has got so many evidences for that to prove. So that's what in 3000 BC only Egyptians were used the iron powders to make the tools. So how they used to make the tools, how they get the solid iron. They don't have. So they don't have any iron blast, nothing. They don't have furnaces, nothing they have. But how they used to make these things? So they say these are all the foundations for the concept of powder metallurgy. Okay. Going further back in time, the art of pottery, terracotta, was known to the prehistoric man. Upper Paleolithic period, around 30,000 years ago. Dough for making bread is also a powder material bound together by water and inherent starch in it. Baked bread in all its variety, perhaps one of the first few steps of processed food man ate. Roti is a form of a bread. Is powder. So just like a flour, whether it is a wheat flour or jute flour, whatever it might be. You will going to get a bread or you're going to get a roti. Everything is in the initially the raw material is in the form of a powder. Just like how you make a roti at your home, at your place. So powder, that is a flour, you will going to bind it with a water, okay? And then you will going to bake it, you will going to put it over a tawa, and then you will going to get it. The same thing the bread was also. The dough for making bread was a powder material bound together by water and inherent starch in it. Baked bread in all its variety, and it has one of the first processed food man ate. This is how the breads were used to make. They say this is the first food processed food for the man which we used to eat. Then recently, so later part of the technology, what has been developed, the modern renaissance of powder metallurgy began in the early part of the last century, when technologists tried to replace the carbon filament in the Edison lamp. The commercially successful method was the one developed by William Coolidge. He described it in 1910 and got a patent for it in 1930. This method is still being used for manufacturing. So Renaissance in the sense how it has been taken forward. So what is the scope of the powder metallurgy? How it has been developed over a period of time. So what it says is the modern Renaissance is started, that is powder metallurgy has started in the early part of the century, where the carbon filaments were replaced. Try to replace the carbon filament in the Edison lamp. And he commercially successful. He developed one method, that is William Coolidge, and he got a patent in, of course, it is in 1910, and he got a patent in 1930, and still this is the method, what is the manufacturing method, but still it is been using for making the film. The wars and the post-war era brought about huge leaps in science, technology, and engineering. New methods of melting and casting were perfected, thereby slowly changing the metallurgy of refractory material. The powder metallurgy techniques have thereafter been used only when their special properties were. So this is just what we call it as the Renaissance. So since how it has been, the technology has been moved it, and how they have powder metallurgy has technology has been developed, and it has been progressed. It has progressed. So even the wars and post-war eras, which brought a lot of changes in the technology and engineering, and these changes will also brought changes in the concept and the process of powder metallurgy. And they started new methods of melting and casting, and thereby, so they have got so many changes they need to do. Okay. And powder metallurgy techniques have thereafter been used only when their special properties were. Yeah. Coming to this one important point that comes out, the entire material need not to be melt to use it. Not necessary here. In the case of a powder metallurgy, you need to melt the entire material so that you can bind or you can fuse to get a final product. The working temperature is well below the melting point of the major constituent, making it a very suitable method to work with the refractory materials such as tungsten, molybdenum, titanium, niobium oxides, and carbides. It began with the platinum technology about 4 centuries ago. In those days, platinum was refractory and could not be melted. Means the refractory materials, just like a tungsten, molybdenum, oxides or carbides, they were not used for making the products because they are refractory. Because of the refractoriness, they could not able to bind it together to form. But here, the powder metallurgy technique, working temperature is well below the melting point of the major constituent, making it a very suitable in the sense the temperature at which the products be manufactured using powder metallurgy will always be less than that of its melting points or melting temperature. So therefore, 4 centuries ago, they have started with the platinum technology, whose melting point was 1774 degrees centigrade, and it was treated as the refractory, and they could not be melted. So here melting is not required. Entire material is not need to be melted. That's what we put it in the first sentence. The entire metal material need not to be melted to fuse it. Okay. So that's the reason why the powder metallurgy concept is one of the modern manufacturing technology where the materials which cannot be processed or which cannot be used for making the products from other methods can be used by using powder metallurgy. Powder metallurgy processing technology in which parts are produced from metallic powders. Usually, during powder metallurgy powder metal production, the powder is compressed into a desired shape and then heated to bond the particles into a hard, rigid mass. So only two processes here involved in powder metallurgy production, powder metal parts production. Powder, making the powder, once the powders are being manufactured or obtained, and the powder is compressed and it is being pressed into a desired shape, and then it is being sintered or heated, we can call it as, to bond the particles into a hard or rigid mass. So pressing is accomplished by a press-type machine using a punch and a die tooling designed specifically for part to be manufactured, and sintering is performed at a temperature below the melting point. In the sense, pressing in the sense, once the powders are ready and it has been put into a punch and a die cavity, and it is being pressed and it is being compressed or it is being compacted. Once it is being compacted, so we will going to get a desired shape, okay, and then we will start heating or sintering, and the sintering will be done at a temperature below the melting point of the metal, so that the powders gets bonded together and it forms a very hard and rigid solid part. This is the basic process what it is involved in the powder metallurgy process. Next is why this powder metallurgy is important. Let's quickly just quickly go for this. Powder metallurgy parts can be mass produced to a net shape or a near net shape, eliminating or reducing the need for subsequent machining. That's what I was talking about first slide. Powder metallurgy process wastes or very little material. About 97% of the starting powders are converted to the product when made with a specified level of porosity and produce porous metals. Example, filters and all those things. Slide was there. And certain metals that are difficult to fabricate. This was tungsten filament, molybdenum, or platinum. They're having very high melting temperatures or refractory materials for which you cannot process with different manufacturing processes. You can make the parts out of this tungsten filament, what we were talking in the first slide. Fabricated by other methods can be shaped by powder metallurgy. Certain alloys, alloy combinations, and ceramics made by powder metallurgy cannot be produced by any other methods. These are very important things. So there are certain quite alloy combinations where we cannot make the parts by using such combinations by any other methods. So we're going to list it out where what are such combinations in the later part. And ceramics, so they are also been totally not used in any other methods for making the parts. But using powder metallurgy, we can use both the things, allowing combination and the ceramics. We can produce the parts. This is another one important point of powder metallurgy. Powder metallurgy compares favorably to most casting processes in dimensional control. Powder metallurgy production methods can be automated for economic production. Quite easily to understand. Now, when to use powder metallurgy? This is another one important concept. Because powder metallurgy, even though it has got so many merits, a little bit of disadvantages which makes the powder metallurgy cannot be used in all the sense. Okay. The powder metallurgy can be used when the competitive with the process such as casting, forging, and machining as a competitive. Used when melting point is too high. Let's just take a tungsten and molybdenum. Reaction occurs at melting, zirconium. Too hard to machine. Very large quantity. Near 70% of the powder metallurgy part production is for automotive applications. It has good, when you require good dimensional accuracy, need to have a controllable porosity. Size range from tiny balls to a ballpoint pens to parts weighing 100 pounds. Most are around 5 pounds. So this is the when we supposed to implement or when to be supposed to use the powder metallurgy. Basically, there are so many points they have listed out there where we can use this powder metallurgy technique. The most important thing is when the melting point of the material is too high. So tungsten and molybdenum, these two materials are very high melting points. So when you want to make parts out of these two materials, so we don't have any other manufacturing methods to produce the parts using these materials. In such cases, we can make use of the powder metallurgy. And also, if you take a zirconium, it has got it reacts at its melting point. And in such cases, when we want to make a product by zirconium, so in such cases also we need to use powder metallurgy. And some materials, when you find materials are very hard to machine, in such cases, and when large quantity is required, okay, and when we require very good dimensional accuracy, and when we need to have a controllable porosity, and when we need to have the components whose sizes vary from very tiny balls or ballpoint pens to a parts weighing 100 pounds. So quite a wide range of applications where we can make use of a powder metallurgy technique. Coming to the applications of powder metallurgy, the most important thing here is electrical contact materials, heavy duty friction materials, self-lubricating porous bearings, powder metallurgy filters, carbides, alumina, diamond, cutting tools, structural parts, magnets, servets, and more such as high technology applications. This is the quite regular way of quite regular applications of powder metallurgy. General applications, what we're looking at basically for electrical contact materials, heavy duty friction materials we can use, and self-lubricating porous bearings, filters, carbides, and like that. There are so many powder metallurgy we have applications. And when it comes to the high-tech applications of powder metallurgy, so high-tech in the sense the components which are used in air and spacecrafts, heavy machineries, computers, automobiles, etc. In such cases, we have anti-friction products, friction products, filters, electrical contacts, sliding electrical contacts, very hard magnets, very soft magnets, refractory material parts, products, hard and wear resistant tools, ferrous and non-ferrous structural parts, right? Quite a number of applications across air and airspace craft. Next comes powder metallurgy merits. The most important thing here is the main constituent need not to be melted. So as in the case of a casting, as in the case of a forging or extrusion, everywhere when you look at those different methods, the main constituent is melted above its melting point, and then it is in formed to get a different required shape and size. Unlikely in powder metallurgy, not necessary to be melted. So main constituent is not melted, and the product is porous. And most important thing is you have a control. You can control the porosity. So where this is not possible in any of other different methods what we are having, especially in the case of filters. So where porosity is very important in products. So you can control the porosity in the case of powder metallurgy. And of course, controlled porosity is for self-lubrication and filtration uses. Constituent that do not mix can be used to make composites, each constituent retaining its individual property. Another important thing with the powder metallurgy is you can produce or you can process composites. So when you want to get a composite with the two different materials which do not mix by a regular stir casting technique or this casting, whatever it might be. In such cases, we can go for a powder metallurgy, where you can mix it to a proper mixture, and then without each constituent retaining its individual property. This is another one merit of powder metallurgy. Near net shape is possible, thereby reducing the post-production cost. So as we were discussing in the first slide, we can produce powder metallurgy to a near net shape. Once produced to a near net shape, all the post-processing cost has been reduced. So therefore, precision parts can be produced, the production can be fully automated, mass production is possible, production rate is high, overhead costs are low, break-even point is not too large, material loss is small, control can be exercised at every stage. So in the sense, so once you get a part for a near net shape, okay, so we can easily get reduce the number of costs. This is another important thing what we should remember here. So we can reduce the production cost and we can reduce so many aspects over there. So therefore, the material loss will be very small and control can be exercised at a very stage. You can control whatever the things, whether the porosity control or density control, whatever it may be, you can control over and you can have a control over each and every. Of course, some of the advantages I have over here, virtually unlimited choice of alloys, composites and associated properties. Can be very economical at large run sizes. Means when you have to produce lakhs of parts, okay, this is very economical. So powder metallurgy finds most economical when you have to produce the parts in mass. Long-term reliability through close control of dimensions and physical properties, very important thing. Wide latitude of shape and design, and very good material utilization. Means we can have unlimited choice of alloys. You can use any alloys, plenty of alloys, plenty of composites you can make use of. And most important thing is the refractivity. And they are long-term reliability, and you can have a close control over the dimensional and the physical properties. And most important thing is very good material utilization, and utilize the material to a larger extent. Okay. And the last thing what we discussed now is the limitations and disadvantages. High tooling and equipment costs. High tooling and equipment costs. Metallic powders are expensive. Problems in storing and handling metallic powders. There is degradation over a time, fire hazards with certain metals. The limitations on hard geometry, because metal powders do not readily flow laterally in the die during pressing. Variations in density throughout a part may be a problem, especially for complex geometries. Porous, not always desired. Large components cannot be produced on a large scale. Some shapes are difficult to be produced by the conventional powder metallurgy. Okay, whatever, the merits are so many that powder metallurgy as a forming technique is gaining popularity. So for time being, I will just stop at this point. So if you have any clarifications, and you can ask me. So tomorrow's class, we will going to continue the same thing here. Anybody having any clarification, you can discuss here. Tomorrow again, we will be having the same concepts. Powder metallurgy will be continued tomorrow. Anybody has got any doubts, you can discuss with me. Anything to ask? Any clarification? Any doubts? Anybody can ask. Time is running out for me. Okay, if you have any doubts, if you don't have any doubts, thank you.